Exercise F1, Rate of Change. In class, we learned the formal term for rate of growth as being rate of change for linear relations. And to figure out the rate of change of any linear relations, we have to use the formula rate of change equals to rise over run. So again, we have to pay attention also to the direction. When you're going from a higher point to a lower point, the rise is actually negative to show you're going down. Run, if you're going from left to right, is a positive run. If you're going from right to left, is a negative run. Number 1, complete the table. So for each graph, we're going to calculate the rate of change and also write down what the rate of change represents. So to do this part, you will have to pay attention to the y-axis and the x-axis labels, okay, or dependent and independent variables to give you a sense of what the rate represents. Okay, first graph, journey of a car. To calculate the rate of change, you can pick any 2 convenient points. So you have a lot of options here, but the most convenient point, well, to show a bigger triangle would be the first and the last point. If you don't like that, you can also use 0 to 1, 80. That works too. But with this big triangle that I have drawn, my rise is going from 0 to 400. So rise is 400. Run is from 0 to 5. So run is 5. Therefore, my rate of change is 400 over 5, rise over run, which works out to 80 kilometers, the unit for the dependent variable, per hour, the unit for the independent variable. And this shows the average speed of a car is 80 kilometers per hour. On the second graph, journey for a cyclist. Now here I could have picked 0 and 1, 15, 0, 0, 2, 30, any one of those. Okay, I've decided to draw a smaller triangle this time. So my rise is from 0 to 15, which is 15 units. My run is 0 to 1, which is 1 unit. Rate of change, 15 over 1, or 15 kilometers per hour. Again, this is the average speed of a cyclist, which is 15 kilometers per hour. Third graph. So the diagram doesn't show you some points, so you have to pick it smartly. You always want to look for points that are easy to tell. So what is the scale going up by? 1, 2, 3, 4, 5. So we're going up by 1 along the gas used axis. How about distance driven? Well, I'm going 2 grids as 30, so it must be 15, 30, 45, 60. We're going up by that amount, okay? Once this is clear, then you go, well, let's draw a reasonable diagram, a triangle. Well, it looks like the last point here, 10 and 150, is quite easy to use. So from 0 to 150, the rise is 150. And the run from 0 to 10 is 10 units. So the rate of change is 150 divided by 10, which is 15. Unit is dependent variable first, so kilometers per liter. This shows the rate of gas consumption for a car is 15 kilometers per liter. So 1 liter can take the car drive a distance of 15 kilometers. Okay. Catering costs for dinner guests. So once again, what are some good points to use? Is this random spot here good? No, because I can't tell what it is. Is this point here okay? Yep, that's okay because I can tell that this is 20 guests and at a price of, well, between 400 and 600, and this is right on the grid, so 500, okay? But what's even easier is that 0, 0 is here. Well, this point is right above 40 guests and it's right at 1,000. So let's use this. Rise is 1,000, run is 400. Rise over run turns into $25 per guest. So when we are dealing with money, we put the $sign in front of the number and then per guest at the end. So the meaning is the catering cost for dinner guest is $25 per person. Number 2. The Jasper Tramway is a cable car in the Canadian Rockies. The graph shows how the cable car's height changes on the 7-minute trip. A. What are the initial and final heights to the nearest 100 meters? Okay, so we have to make sure we understand what the graph is showing us. So there's a title, Jasper Tramway Trip. The horizontal axis, x-axis, or really time axis in minutes shows us the trip from 0 to 7 minutes. And also the vertical axis, sometimes you call it the y-axis, dependent axis, or here's the height axis, shows that the height of the tram during the journey. So we're finding the initial height, meaning at time 0 at the very beginning of the trip. The tram is starting at this height here between 2,000 and 2,400, so it must be 2,200 meters high. And then at the end of 7 minutes, well, we ended up here, which is sort of halfway between 1,200 and 1,400 meters, so it must be around 1,300 meters. So now we have to calculate the approximate rate of change. We start with the rise. So we start from, let's say, the beginning, 2,200 meters. We went down to 1,300 meters. So this is 900 units down. Remember, down means negative 900 rise. How about time? We go from 0 to 7. We're going to the right. So run is 7 positive. The rate of change is negative 900 over 7, or negative 129 meters per minute. So this is showing me that the cable car is descending, is coming down every 129 meters in 1 minute. Number 3. A group of friends is hiking 15 kilometers around the lake. It takes the group 30 minutes to hike the first 2 kilometers. The group keeps hiking at this rate. A. Complete the table from the start at 30-minute intervals and graph the data. So here, time 0, we assume they're starting, so there's no distance yet. The question says it takes the group 30 minutes to hike the first 2 kilometers, so 30 is 2. So if they hike for another 30 minutes, they are at a distance 4 kilometers from the lake, from the starting point, and so on. Okay, so every 30 minutes, so keep adding 30 in the first column, distance increases by 2. So you can graph this data. So 0, 0 is here, 30 and 2, 60 and 4, 90 and 6, and so on. After you have a first few points, because the group is going at a steady rate, it will be a linear relationship. So connect the dots and extend the line all the way across the grid. Don't forget to give your graph a title and label the axes, time and distance. Part B. Determine the rate of change. What does it represent? You can now pick any 2 points on the graph to figure out your rise over run. I'm going to use an easy point as 0, 0, and maybe a larger triangle than the first point, so I'm going to use 60 and 4. You can use anything from like 120 and 8, 150 and 10, and so on. That works too. So now what's our rate of change? We're going from 0 to a height of 4, or distance of 4 kilometers, rise is 4. Run from 0 to 60, so run is 60, so I have 4 over 60, simplify that to 1 over 15. How long will it take for the group to complete the hike? Show your work. So now we need to remember that the question told us the hiking trip is around a 15-kilometer path. Because we have the graph here, we can actually interpolate. We can estimate. So go to a distance of 15 kilometers. And what time does it show you? Well, it is halfway between 210 and 240. So it must be at 225 minutes. Or remember, you can come up with a pattern rule of these linear relations. This is starting from 0, so the initial value or the adding part is 0. The rate of change is the same as rate of growth, or the multiplier, so your rule of this line is actually y equals 1 over 15x. So at a distance of 15 kilometers, so that's y, this is equal to 1 over 15 times x. You solve this equation, you multiply both sides of the equation by 15, you also get 225 minutes. That's not bad. D. What is the average hiking speed in kilometers per hour? All right. So 1 hour is the same as 60 minutes. Now let's take a look at what we already know. We have a table, we have a graph, right? So at 60 minutes, the group hiked 4 kilometers. What does that mean? 60 minutes is also the same as 1 hour. So in 1 hour, the group hiked 4 kilometers. What does that sound like to you? Isn't that just your average speed of 4 kilometers per hour? And you're done. Number 4. Tyler wants to buy a fuel-efficient car. Okay? The fuel consumption for 3 different cars is shown in the table. A. Determine the rates of change for the 3 makes of cars, so 3 different brands. Give your answer to 1 decimal place where necessary. Okay, so fuel consumption, usually we say that how many kilometers does a kind of car drive for 1 liter of gas. So when you set up a proportion or your rate of change, you will take the distance driven, so for car A, 880, and divide that by the amount of fuel used, 55. In a way, this is also the same as thinking about what we used to call unit rate, kilometers per 1 liter. So you can work this out. Car A has a fuel consumption of 16 kilometers per liter. Car B, you take 1,100 kilometers divided by 82 liters, works out to about 13.4 kilometers per liter. And car C, 850 kilometers divided by 42 liters, works out to 20.2 kilometers per liter. What do these rates of change represent? They all represent the distance driven for 1 liter of fuel used. And C, which car should Tyler buy and why? Well, if he's buying a car, I think one of the consideration is with the same amount of fuel, you probably want to go further, right? To save money. So which car allows him to drive a longer distance or the longest distance with 1 liter of gas? First one drives 16 kilometers. The second car drives 13.4 kilometers. The third car drives 20.2 kilometers. Of course, he is going to pick car C for the most fuel efficient car.